My name is Ishal Abdul Halain. Welcome to my video on the introduction to assembly language. This is a 4-part video series that will help you understand the fundamentals about assembly programming for the 68K microprocessor. This first part of the 4-part video series explains machine language, assembly language, and lists all of the addressing modes found in the 68K microprocessor. Machine language is a low-level language, comprised of instructions encoded in binary format that is understood and executed by the microprocessor. The language is machine-specific, meaning that, for example, the language spoken by the 86K microprocessor is not understood by another type of microprocessor. It is considered low-level due to how it is written. Machine language comprises of only logic ones and zeros and cannot be easily understood unless you have a very strong background in low-level programming languages, such as assembly. Machine language is obtained by translating programs written in higher-level languages such as C or Java. In contrast to machine language, they are considered high-level because their instructions are made from words that have grammar that is quite similar to the English language. In general, the programmer writes what we call object code that is translated to machine language for the microprocessor. In any programming language, there are a lot of instructions that can be used by the programmer during the course of writing a program. These instructions can be subdivided into many types according to their function. Here is a list of the types of instructions that a microprocessor is able to execute. 1. Arithmetic operations. 2. Logic operations. 3. Program flow operations. 4. Data transfer. 5. Shift and rotate. 6. Bit manipulation. 7. Binary coded decimal. 8. System control. We will study some of the instructions from each of these types in a later video. Assembly language is considered to be a low-level programming language. It is considered low-level because it is written using mnemonics and have a very primitive grammar structure that precisely instructs a microprocessor on what to do. It can be translated directly into machine language using a utility program known as the assembler. I am going to show you the process on how an assembly language program is translated into machine language. A programmer writes an assembly language program, called a source code and stored in a file that usually has a star.asm extension. This file is processed by a utility program called an assembler, whose task is to produce machine code for the microprocessor to execute. The assembler outputs two formats of machine code, called the list code and an object code. Both of these codes contain the same program instructions encoded in machine language. The major difference between the two is that the list code is encoded as hexadecimal and contains address locations where all of the program's instructions are stored in memory, while the object code is raw unformatted machine language. The object code is then processed by a program called the linker. Its job is to reformat the raw machine code such that the bits and bytes are properly arranged for the microprocessor to digest. An executable file is produced by the linker. This executable file contains the machine language instructions that were arranged by the programmer in the source code during the assembly program writing phase earlier. The executable file is executed by the microprocessor. The whole process of obtaining an executable file from a source code is known as the assembly process. Now we will have a look at a sample list file and source code written for the 68K microprocessor. Here is the source code. At this point, do not concern yourself on the instructions you see. I just want to show you the format. This assembly language source code can be divided into 4 columns. The leftmost column shows the corresponding lines of instructions in the program. In this case, the program has 11 lines. The second column are used for labels. Similar to high-level languages, labels correspond to points of a specific instruction where the program jumps to when needed. The third column are the instructions of this program. Instructions are also known as opcodes. The final column is where the operands or instructions are placed. Operands in assembly is defined as data or locations where data is processed according to a specific instruction. For example, in line 2, the instruction reads CLR.W, while the operand is register D0. This line instructs the 68K microprocessor to clear the contents of the first 16 bits in register D0. Now you see the list code. It contains the machine language equivalent to the program on the left, but in hexadecimal values. It is also formatted in 2 columns. The left column corresponds to addresses in memory while the right column is the equivalent machine code for all of the instructions in the program. In short, The list code shows memory contents that contain the translated machine code of the program. Let's try to understand the list file now. Look at the source code's first line, ORG 8000. This instructs the assembler to store the translated machine code program in memory starting at address 8000, thus, the first instruction in line 2 in the source code is translated to machine language and stored at memory 8000. Instruction CLR.WD0 is translated to 4200 and is 2 bytes long. Since it is 2 bytes long, the next instruction will be stored at address 8002. At 8002, 123C0011 corresponds to the instruction at line 3 in the source code. It is 4 bytes long. Thus the instruction in line 4 in the source code is translated and saved beginning at address 8006 as 207C00008001E. The translated instruction requires 6 bytes to store. Thus, the next instruction is stored at address 800C. I think you have got the idea on what a list code is. Now let's see an overview on the 68K microprocessor instructions. There are 93 instructions available. The instructions are divided in 8 types which are listed here. For the 68K microprocessor, most of the instructions follow this general syntax, an opcode followed by an operand. Opcodes are also known as the instructions, and in assembly language they are written as simple mnemonics. These mnemonics are simple verbs similar to words in the English language, for example, move, add, sub for subtract, and JMP for jump. Operands are basically data that can be subdivided into a source operand and a destination operand. However, at this point, it is important to understand that operands are data that can be either 1 byte long, 2 bytes long, or 4 bytes long. A 2 byte long data is known as a word, a 4 byte long data is known as a long word. An instruction set is a document that lists all of the instructions used for programming the 68K microprocessor. Before we go on any further, we should know that a lot of the instructions for the 68K microprocessor can be used to access memory. This is done because operands are sometimes stored into memory or retrieved from memory. It is a fact that all of the instructions can only access even memory addresses. For example, to move data into address 010012 is permitted because the address is even. However, attempting to move data into address 010013 is not permitted because it is an odd address. We have arrived at our final slide. Addressing modes. Recall that I mentioned that operands are data that the instruction works. They can reside in memory, they can be specified directly in the instruction, they can be found in registers, or they can come from peripherals such as sensors connected to the microprocessor. Thus, an instruction or opcode must retrieve operands from many sources and by many methods. The method an opcode obtains an operands is known as the addressing mode. The 68K microprocessor has 14 addressing modes listed here. Pause the video if you need to copy them down. In parts 2, 3, and 4 of this video series, we are going to study all of them, except number 12. So, please stay tuned for parts 2, 3, and 4. Thank you for your time. Have a great day.